Hello everyone, in this lesson we're going to discuss some basics of antiderivatives. So what is an antiderivative? An antiderivative of f of x is a function such that the derivative of that function is equal to the original function. The symbol that we use to indicate finding an antiderivative is called an integral sign. So a lot of times when we mean to find the antiderivative, you'll be told to take the integral of that particular function. The inside function that we're taking the antiderivative of is called the integrand, and the dx, that x part of it, is the variable of integration. When you're first starting to look at antiderivatives, we only look at single variable functions, but once we have multiple variables within a function, having that variable of integration is extremely important because it tells us what variable we're taking the antiderivative with respect to. Some properties of integration is that if I have a constant, so that constant represents any real number times a function, I could take the function out of the integral and integrate the function as normal with whatever rule I need. That's similar to the differentiation rule. If I have a constant times a derivative, that constant can be pulled out. If I have the integral of two or more functions that are being added or subtracted, I can find the antiderivative of each individual function. Again, similar to the derivative rule, where if I have multiple terms that I'm taking the derivative of, I can differentiate each term. Same thing here, I can integrate each term individually. Lastly is the rule that we're going to be using primarily in this video, which is the power rule for finding antiderivatives. So this is just the opposite of what the power rule for derivatives are. The last rule we have is the power rule for integration. So if you remember back to differentiation, we had a power rule for differentiation as well. The power rule for differentiation was that we take the exponent and multiply it by the function and then subtract the current exponent by 1. Here, since the antiderivative is just the inverse of the derivative, we're going to do the inverse operation here. We're going to add 1 to the current exponent and then divide by that new exponent. One thing to take note of is that we cannot apply this rule if the exponent is equal to -1. We're going to talk about why that's true in another video, but for now, let's just keep with the rule that we cannot do the power rule for when the exponent is -1, so don't forget that. The other thing that we need to take note of is that now when we take an antiderivative or an integral, we need to add c, where c is called the constant of integration. So the reason why we need to have that c is because when we take derivatives of constants, what happens to that number? Well, the number turns into 0, so we kind of lose that part of my function. So when we take the antiderivative, we need to make up for losing that constant. That's where the c comes in. Sometimes we're not going to care exactly what that number c is. Other instances, which we're going to see in some of our business applications, that c is going to be very important to us because that c is going to be our initial condition. So now let's take a look at a couple examples where we are applying this power rule as well as applying our other two properties, which was multiplying by a constant value as well as integrating term by term. So the first problem I have here is the integral of x to the 13th dx. So by my power rule, I'm going to add 1 to the exponent and divide by the new exponent. Then, of course, add our constant of integration. And that's all there is to it. If I have a negative exponent, as long as that exponent isn't a -1, we're going to follow the same process. We're going to add 1 to the exponent, divide by the new exponent, and add the constant of integration. Now here, I didn't show this in the previous problem, but I'm going to show it here how I would rewrite my answer to kind of clean it up, because we always want to try to simplify and clean up our answers. I generally like to take the variable out of the fraction. So I write the fraction by itself, -1/4, and then the variable next to it. You may even see answers simplified with positive exponents instead of leaving the negative, I always just leave the negative exponents. I think they're easier to work with. So that's generally how you're going to see me writing my answers. The next problem I have is when we have multiple terms. So I have x to the 6th minus 4x plus 7 dx. So I'm going to integrate term by term. X to the 7th over 7, so that's just like our previous two examples. This middle term, we have a constant. So remember the first rule of antiderivatives is that if I have a constant times the function, I'm going to integrate the function and then multiply by that constant. So the antiderivative of x is x squared over 2, and then I'm still multiplying by that negative 4, so it's going to stay out front. Lastly, we have the 7. So again, we have a function times a constant. So 7's my constant. Then we think, what is our function? Well, our function, we can think of it like x to the 0. X to the 0, we know just simplifies to 1 because as per the exponent rules, anything to the 0 power is 1. I can add 1 to this exponent, so now that makes it x to the 1. Divide by the new exponent, which is just 1. So if I just look at that, x to the 0, x to the 1 over 1, plus my constant. So if you remember back to differentiation, if I took the derivative of x, that always equal to 1 because the exponent here was 1. We multiplied by it and then subtracted the exponent by 1. That gave us x to the 0. So again, this is just the inverse operation. We're just doing the opposite here. So the antiderivative of 7, or 7x to the 0, which you don't have to rewrite, but maybe think about it that way in your head, will be 7x. And then, of course, adding my constant of integration. Last step is to always clean up. 1/7 x to the 7. Negative 4 divided by 2 will give me a negative 2x squared plus 7x plus c. In my last example, I have a few different types of terms. I know I'm just adding in a square root, but that doesn't change anything that we've done so far. The power rule is still add 1, divide by the new exponent. So remember that this is x to the 1/2. So adding 1 now makes this x to the 3/2. Divide by the new exponent. Minus, this is, remember, 3x to the negative 2. So this is going to be 3x to the negative 1 divided by negative 1. Negative 5x cubed will be negative 5x to the 4th over 4. Plus 1 will be plus 1x plus c. Of course, we want to simplify this. When we divide by a fraction, that's the same as multiplying by its reciprocal. So you might get into the habit of, instead of writing this, where we're making this complex fraction, you might say, okay, I'm going to add the 1 to the 1/2. That gave me x to the 3/2, and then multiply by its reciprocal, because that's the simplified form. So that's 2/3 x to the 3/2. Negative 3 divided by negative 1, that's now a positive 3x to the negative 1. Minus 5/4 x to the 4th plus x plus c.